Okay, so where did we leave off last time? We've talked about computer hardware, and then we detailed the hardware. We split the hardware to the hard drive and the RAM and the CPU. We detailed each part's role in the running of the computer. Okay? But these are only the essential parts, the main parts. We have multiple other parts that work in tandem in order for us to be able to use the computer. Okay? So, for example, in order for a computer to run, we need it needs electricity. Where do you think the computer gets its electricity from? If you guys have any idea.
I think electricity will operate the motherboard or motherboard.
Yes, the motherboard is responsible for the distribution of electricity to the other parts of the computer. But how does the motherboard receive its supply of electricity? That's what I want to know.
From extension cord, or like it's like when you plug an extension cord related to the electricity.
Okay, so you think that it directly gets its electricity from the wall?
Yes.
However, the motherboard gets its electricity not directly from the wall, but from another part that is essential for the running of the computer, which is called the power supply. Now, the power supply's role is to take electricity, receive electricity from the wall, and then it adjusts the current and the voltage uh, to be safe for the other parts to consume. So the motherboard gets its electricity from a cable which is called a 24 pin cable. Okay, first, before we take a look at that cable, let's first take a look at what a power supply looks like. Okay, for example, this is what a power supply looks like. This is a basic one. Now, this one is a 1000 watt power supply. Okay, notice it has a bunch of cables coming out of it. For example, the biggest one, which is this one here, is called a 24 pin cable, power cable. Okay, 24 pin power cable. Power cable.
Sir, I couldn't see.
Just a moment. Is this screen not visible to everybody?
Now I can see. It's okay.
Okay. So the cable you see before you is called a 24 pin power cable. Its name is simply the number of pins it contains. We have 24 pins. This cable, this cable slots into the motherboard directly. Okay. For example, let's see an example. of a motherboard, and let's see how the cable would be positioned. Okay, if you can see, this part right here is where the cable will be slotted. Okay, this cable is designed to go into this connector. Okay, this is the main supplier of the motherboard, the main electricity supplier of the motherboard. Okay, from here the RAM, the motherboard receives its supply of electricity, and it can then divide this electricity between the parts. Okay, the different parts. A little bit goes to the CPU, a little bit to the RAM, to the storage, to the different components. Okay, for example, here, if you notice here, Lightning Gen M.2, what does this connector stand for? This connector we can plug in M.2 SSDs. What is an M.2 SSD? It's a type of disk. Okay, what do we mean disk? Disk meaning it's a type of storage. For example, last time we talked about hard drives. We kept it general. We only talked about hard drives. Okay, but we have different types of SSDs. Okay, different types of SSDs. Let's go and
Sir,
them. Yes.
sir, is there any difference between the power? Is there any difference between the power supplier in a normal computer and the laptop?
Yes, there is a difference. The difference is that a laptop's power supply is located in its charger. Okay, the charger does the job of a power supply for the laptop. Okay, the charger takes electricity. For example, in most laptops, the charger takes in 220 volts. Yeah, and it converts that current into I don't know. Some laptops have 30 watts, can run on 30 watts. Some of them 45 watts, depending on the laptop. But that job, the job of the power supply, is executed by the charger, the laptop's charger. Okay, and then the laptop receives
Okay.
its electricity normally through the connector. Okay.
Okay.
There are several differences between desktops and laptops, but the main components essentially do the same jobs. Okay, for example, the charger does the work of the power supply. For example, the motherboard. The motherboard will be more. How shall I say this? It will be smaller. The parts won't take as much space. Okay, because space is something that you need to optimize in a laptop. You have two constraints, three constraints: battery, space, and heat. These three constraints you have to take into consideration when you're making a laptop. For example, your laptop shouldn't take as much space as a desktop, for example, because the main purpose of a laptop is being portable. You can carry it around with you wherever you go. This is one constraint. Second constraint is the battery. The battery, you need your laptop to last as long as possible, okay? So in order for you to preserve the battery, you need to lessen the power consumption of your parts. For example, a desktop CPU will consume much more electricity than a laptop CPU, okay? Because the desktop CPU doesn't have power constraints. It doesn't run on a battery, okay? It runs off the electricity on the wall, okay? But the laptop has its battery to think of, okay? For example, the third constraint is heat. Okay, laptops get harder than desktops because there isn't as much space to cool the parts of a laptop. Are we clear on that?
It's clear.
Okay, so moving on. Now, as we said last time, we have different types of hard drives. We call them hard drives. Yes. Yes, please go ahead.
Can you please explain slowly because my network is so bad?
No problem, no problem. So what I've said is the difference between a desktop and a laptop can be summed up in three things, three constraints that control or restrict how performant or how big a laptop can get. The laptop first needs to be portable. Needs to be portable. That's the whole purpose of a laptop. You can take it with you wherever you go. Second is power consumption. Your laptop's battery should last as long as possible. So you shouldn't make a laptop with parts that consume so much electricity. Okay? The third is heat. We all know that computer parts, especially the CPU and the GPU, generate tons of heat. So you should minimize the heat that your parts generate in a laptop in order for it to be viable, okay? Because you don't have as much space for cooling to cool the laptop, okay? But for example, in a desktop, it's not that it is not a problem. It is a problem for you to address in a desktop, but you have much more freedom in a desktop because the desktop has much more space for fans and for coolers and everything, okay? It is not restricted as much as a laptop, okay? If we're clear on that, we can move on to the types of storage devices, okay?
Excuse me, sir.
Yes.
For the third difference is heat. You said minimize the heat in components of the laptop.
Yes.
Is that true?
Yes, you should minimize the heat generation in a laptop. The way you go on about that, you should, the way companies go about that, they use parts that consume less power. Less power generally means less heat, okay? For example, a desktop processor consumes 65 watts of power or more. But generally, you wouldn't find a laptop processor that consumes as much, okay? The maximum, for example, for a laptop part is 30 watts, for example. It consumes less power, and that means it is weaker than the desktop part, but it generates less heat and it consumes less power, meaning the battery will last longer. Okay, it's a trade-off between size, heat, and power. Okay. Is everybody
Sir,
on
can
the
you
same
please
page?
repeat the name of the motherboard? 24? 24 what?
24 pin. No, it's not a motherboard. The 24 pin cable. It's a cable that supplies electricity to the motherboard, okay? It's a cable that comes out of the power supply and it supplies electricity to the motherboard, okay? Because it slots right here
Okay.
in the motherboard. This cable goes right in here and it supplies electricity to the motherboard. Then the motherboard distributes this electricity to the different parts of the computer, okay? So let's talk about the types of storage devices. What we mean by storage devices, I called them last time hard drives. I didn't want to complicate things, so I restricted them to a single type. In reality, we have two types of storage devices. There are mechanical hard drives, the ones we use to this day. We have mechanical hard drives and we have solid state drives or SSDs. We have HDDs, hard drive disks, or SSDs, solid state drives. Okay? The difference is mechanical hard drives or HDDs contain many moving parts. And the way they access data is by moving disks, okay? By moving disks. Consequently, they are slow, okay? However, SSDs are electronic parts. They store data, but the way they access data is by electricity alone. There are no moving parts in an SSD. Consequently, it is much more quicker, okay? It is much quicker. Now, let's see an example of an SSD, of an HDD, a traditional hard drive, okay?
But sir, what is the main difference between them?
The main
Between the
difference
mechanical
is,
ones and
yes, the mechanical ones are slower, much slower than the electronic ones, okay? Anything that is
why slower?
why are they slower? Because the way they access data, I've told you, is by moving parts. Moving parts are considerably slower than accessing data through electricity, electric part. Okay?
Okay, can you give us examples?
Yes. For example, these are hard drives. Okay? This, for example, let's see. This picture will sum up everything, okay? Now, the big one is a mechanical hard drive, okay? It contains many moving parts like CDs, like discs, spinning discs, and it has a needle that is responsible for locating data inside the discs, okay? That's why
Sir,
it
I
is
couldn't
slower.
see the screen, please, sir. Sir,
Yes,
I
I
couldn't
will
see
go
the
back to the
screen.
screen. I will go back to the screen. Don't worry. I will go back to the
Okay.
screen and then we will see in detail the difference between the three types of storage devices, okay? Now, an HDD contains many moving parts, okay? Many moving parts, including disks, spinning disks, and the needle has to locate the data in these spinning disks, okay? That's why it is considerably slower than the SSD, which locates the data electronically, okay? With no moving parts. It accesses the data directly, okay?
Sir, what do we, sir,
So sir,
what do,
it's like the hard drive when it reaches like the program of Word or Excel.
Yes.
Okay.
For example, if
sir,
you
what do we mean by the moving part?
the moving parts, we have moving parts. If
Yeah,
you
what do
see an HDD, yes, a hard drive. Inside a hard drive, it is like this, okay? This is the inside of a hard drive. Notice we have a disk in the middle, and then this needle is responsible for locating the data inside this disk, okay? But the disk is moving.
Oh,
Yeah, so in order for the
okay.
needle to locate different parts of a data, it has to cycle through, for example, many disks like this. The disk has to spin many times in order for the data to be located. Okay, it is slower. Uh, you can
So, sir,
you
it's
can
not
take
like
this as a rule.
it's not what we call. It's not like a CD receptor or a CD reader, but we call it a lecteur.
Yes, yes. This is a type of no. They are not the same. They are connected to the PC through the same interface. We're gonna see it, but they are not the same. Okay, the same mechanism in
Okay.
the old CD readers spin the disks, and then you read the data from the disk to the computer. Okay, the computer reads the data as the disk spins. Okay, but the speed
Okay.
with which the data can be read is considerably slower than the use of an SSD or a solid state drive. For example, for example, uh, we're gonna try and install a program inside the hard drive, and then we're gonna install it inside the SSD, and then see the difference. Okay. For example, in my computer, I have two disks. Okay. I have an SSD, a solid state drive, which I use for the operating system as well as the programs. Okay. And I have an HDD, a regular disk, hard drive disk, which I use for storage, for storing media. Okay. Now, for example, let's see. Let's try to install a program. For example, let's install this program. Before that, let me create a folder, a new volume. Let's call it trial. Okay. For example, let's download this program. Let's wait for it to download, and then we're gonna install it inside the hard drive and then inside the SSD and see the difference. Okay, the difference of how quickly does this program open. Okay. Let's change where this program is installed. this PC. Try. Let's install this program here. Let's deselect these options and accept and install. Okay?
Sir,
Yes.
can we say that the USB flash drive is like a solid, is like an SSD?
No, it is the same type, but it is slower than an SSD. The flash drive.
Yes, it's not like using electric fast.
Yes, it is not like using a regular hard drive. Now we're gonna talk about
Yes,
the interfaces. The difference is in the interfaces used to connect these parts to the PC. Okay, we're gonna talk
okay.
about that shortly.
Okay.